Hello everyone and welcome to IP Study Lecture video. Today I'm going to take chapter number 6 of grade 8 and the name of the chapter is Factorization of Algebraic Expression. So dear student, let's quickly see what are the topics that we are going to cover in this chapter. First of all, we will learn how to find out factors of an algebraic expression. Then we will see how to find out common factors of the given monomial, binomial or any polynomial. Thereafter, we will be discussing about how to find out highest common factor of given algebraic expression. Then we will learn how to factorize an algebraic expression by grouping the terms. Then we will see how to factorize an algebraic expression having the terms having common monomial in each term or having common binomial in each term. And towards the end of the chapter, we will be discussing about how to divide algebraic expression. So without wasting our time, let's start the session. So dear student, we have already learned about what are factors and multiples in the previous grade, right? And we know that any term can be expressed in terms of its prime numbers. So whenever you are factorizing, whenever you are writing factors of any number in terms of its prime number, we call it prime factorization, right? In order to recall that concept, let's take an example over here. Let's take 70 and let's write down the prime factors of 70. So if you write it down, what you will get, let's do it together, right? The next step is, I will choose 5 and then thereafter I will have 7. So it means I can express 70 in terms of its prime factor or in terms of products of its prime factors, right? So I can write it like this, 2 cross 5 cross 7. So this whole process is called prime factorization. So, like we have done prime factorization of number 70, in the same way, we can prime factorize algebraic expression. So, how we are going to do that? How we are going to find factors of an algebraic expression in this way? For that, let's take an example over here. So, let's take an example. Suppose I have a monomial, 3x square y, right? Now, I want to write down its factor. So, like we wrote factors of 70, in the same way we can write factors for 3x square y, right? So what could be the factors of this monomial? Let's see. So I can write 3x square y as 1 cross 3x square y. This is the first case. Secondly, I can write it as 3 into x square y. I'm just breaking the terms, breaking this term, right? Next, I can break it down as 3x square into y. Then I can write it as 3x into y. Then I can also write it as 3xy into x. Then 3y into x or 3y into x square or 3x into y. So on the basis of these expressions that we have just seen here, I can say the factors of 3x square y are 1, 3x, 3xy, 3y, xy, 3xy, x square, 3x square y and 3x square y. So this is how you can write factors of any monomial, right? Now, on the basis of an example that we have taken just now, we can say that an algebraic expression can be expressed as the product of numbers and variables. What we have done here, we have just written the product of the given number, the product of the variable and the number for a given monomial, right? So it is saying an algebraic expression can be expressed as the product of numbers and variables. Each of these numbers and variables is called factor of the given algebraic expression, and the algebraic expression is called the product of these expression, right? So this is all about how to find out factor of an algebraic expression. Now let's see how to find out common factors of an algebraic expression or the algebraic expressions, right? So for that, let's take an example over here. Suppose we have two monomials, right? One monomial is 5x square y and the another one is 11xy square. So first of all, what you will do, whatever monomial given to you, first write down the factors for each monomial separately, right? So let's do it together. For 5x square, let's write down the factors. So we can write it like this as a product of number and its variable, like this, and like this, right? In the same way, for 11xy square, we can write down the factors like this. Now, if you sum up, you will find out the factors for 5x square y are 1, 5x, 5x, x square y, 5x square, y, 5y, xy, 5xy, x square y, 5x square y. In the same way, you can write down the factors for 11xy square. And when you observe these factors for these two monomials, you will come to know that the common factor for both these monomials are 1, x, y and xy, right? So, this is how you are going to find out common factors for given monomials, right? I hope you have understood this concept. Now, let's move on to the next topic, that is highest common factor. So, dear student, this concept is also familiar to us because we have discussed a lot about this concept in our previous grade, right? So, in case of algebraic expression, what is highest common factor? The highest common factor of any two monomials is the greatest factor that exactly divides both the monomials, right? That is called highest common factor of the given monomials. Now, how you are going to find out the highest common factor of any two monomials? In order to understand that, let's take an example over here. It is given here in this example 1. What we have to do? We have to find out HCF of 30 x raised to the power of 4y and 70 x raised to the power of 3 and y raised to the power of 2. So, we got these two monomials, right? This one and this one. And we are supposed to find out HCF of these two monomials. So, first of all, write down the factors of these two monomials separately, right? So, let's do it together. Let's factorize 30 x raised to the power of 4 y. So, the factors are 2, 3, 5, x, y, right? These are the factors of 30 x raised to the power 4 y. In the same way, you have to factorize 70 x cube y square. When you factorize it, you will get these factors. These two steps are done. In the next step, you have to find out the common factors. So, what are the common factors I can see over here? Let me change the color of the pen. So, I can see this 2 is common to both the monomials, right? In the same way, this 5 is common to both the monomials. Next, we have this x common to both the monomials here. And thereafter, we have this y. Now, whatever common factors you have selected for these two monomials separately, you have to write it down. So, when you write it down, what you will get? 2 cross 5 cross x cross x cross x cross y. When you sum up, what you will get? 10 x cube y, right? So, 10 x cube y is the HCF of these two given monomial, right? So, I hope you have understood how to factorize a given monomial, how to find out factors of common factors of monomial, and how to find out highest common factors of the given monomial. So, the next topic is factorizing an algebraic expression when we have common monomial in each and every term. So, how we are going to do that? In order to understand that, let's take example number 1, the first part, that is 18x cube minus 27x square y. So, how we are going to do that? First of all, whenever you are supposed to find out or supposed to factorize an algebraic expression having common monomial, in that case, find out the HCF of the monomial that you are going to subtract or add in a given expression. So, here since we have two monomials and they are getting subtracted, so what you will do, you will find out HCF of 18x cube and 27x square y over here. So, what is the HCF? HCF is 9x square. How you can find out? We have just discussed in the previous portion. We have just finished it. How to find out the HCF of two given monomial. So, you can use that method in order to find out HCF of 18x cube minus 27x square y, right? Once you have found what is the HCF of these two monomial, you have to take it out and then you have to write the remaining part. So this is your HCF for the given algebraic expression. Now what you will do, divide 18x square x cube by 9x square. So what you will get? You will get 2x, right? Then minus sign is there, write minus over here. After that, divide 27x square y by 9x square. When you do so, what you will get? You will get 3y, right? So this is your answer. This is the required answer. Now, in order to understand this concept in a better way, let's take another example. Suppose you have 6x square y minus 8xy square, right? So what you have to do, first of all, you have to find out HCF of these two monomial. And what is the HCF of 6x square y and 8xy square? It is 2xy, right? Write it down separately, 2xy. Next step is whatever HCF you have got, now divide monomial and write it in the bracket. So the first was 6x square y. If you divide 6x square y by 2xy, what you will get? You will get 3x. Then you have a minus sign over here. Put the minus sign over here. Then the next monomial is 8xy square. Divide this 8xy square by 2xy. What you will get? You will get 4y, right? So this is the required expression. So I hope, student, you have understood how to factorize an algebraic expression when a monomial is common in each and every term, right? Now let's move on to the next topic. The next topic is factorizing an algebraic expression when we have a common binomial, right? Now how we are going to do that? In order to understand that, let's take an example again. Let's take example number 4 over here, right? So here what we have to do, we have to factorize 2a x plus 3y plus 3b x plus 3y. So dear student, let me show you one thing. You can see here x plus 3y and x plus 3y. This binomial is common to both the term, right? So what you will do, you will take out this x plus 3y outside the bracket. So what you are left with here, you are left with 2a, right? Then you are left with a plus sign. Put the plus sign over here. And then you are left with this 3b, right? So write 3b over here, right? So this is the required result. This is how you are going to factorize any algebraic expression having a common binomial in each and every term. So I hope, student, you have understood this concept very well. Now let's move on to the next topic and let's see what is the next topic. The next topic is factorizing an algebraic expression using grouping. So what does it mean and how we are going to do that? So a rule is written over here. Let's read the rule together. It is saying rearrange the terms of the given expression so that all the terms have common factor, or if not, try to group in such a way that two terms have common factor. Rewrite the expression using distributive law by taking out factor which is common to each group. So in order to understand this rule, let's take an example. Let's take example number 7 over here. So dear student, you can see we have xy plus 3x plus y plus 3, right? Now I have to group these 4 numbers in such a way that something comes out to be common in both the terms. Okay, so here let me group x, y and 3x together because we have x in both the terms, and let me group y plus 3 like this. So I can see, let me change the color of my pen. So here I can see xy and 3x. So what is common in these two terms? I can see x is common, right? So let me take x common over here. So what I am left with? I am left with y plus 3 plus what is common in y plus 3? Nothing. So I can write 1 because we know that 1 is the factor of each and every number, right? So let me write 1 over here. It won't affect my binomial. So y plus 3, right? Now I can see here y plus 3, y plus 3. I have a binomial in common in this algebraic expression, and we have just discussed this topic, right? So what we have to do? We have to take y plus 3 common. When you do so, what you are left with? We are left with x over here plus sign, and then we are left with 1 over here, right? So this is the required expression. So I hope you have understood how to factorize any algebraic expression by grouping them, right? Now, let's move on to the next topic and see what is there. Now, the next topic is based on these two, how to factorize an algebraic expression using identities. Now, what does it mean? So, dear student, we have some formulas that we can apply to any algebraic expression in order to factorize them. So, the first identity is a square plus 2ab plus b square, which is always equals to a plus b raised to the power of 2, or we can also write it as a plus b into a plus b. The second identity is a square minus 2ab plus b square, which is equivalent to a minus b raised to the power of 2, which can also be written as a minus b into a minus b, right? So, in order to understand this, how we can use this identity in order to factorize an algebraic expression, let's take example number 11 over here. In example number 11, we have to factorize this expression. Here we have 9x square plus 30x plus 25. So, according to this identity, the first one, we can see each and every term is connected by a plus sign, right? And in this algebraic expression that we have to factorize, we also have all the signs plus. So, it means we can try to apply this identity over here. So, what is 9? What number's factor is 9? We know that 9 is a square of 3, right? Whose square is 9? The number 3, if you square it, you will get a 9 over here, right? So, can I write 9 as 3x whole square? Can I write it like this? Yes. Then after that, we know that 25 is a square of 5, right? So, in place of 5, can I write 5 raised to the power of 2? Yes. Then plus 2 into what is a over here? This is a. And what is b? B is this one. If you multiply it, what you will get? You will get 30x only. So, I can compare this expression with this identity. Yes. So, it will become a square plus 2ab plus b square, which is equal to a plus b raised to the power of 2. What is a here? 3x plus what is b here? 5, right? So, 3x plus 5 raised to the power of 2 is the required result. Or I can say 3x plus 5 into 3x plus 5 is my answer for this algebraic expression, which I have just factorized, right? So, I hope you have understood how to factorize an algebraic expression using an identity. Likewise, you can use this identity as well in order to factorize any algebraic expression. So, I hope you have understood this topic very well, right? Now, student, let's move on to the next topic and let's see what is there. The next topic is how to factorize a quadratic trinomial, right? So, we have a method that we call splitting the middle term that we are going to learn in this particular section. So, in order to understand that method, let me take an example for you. So, here let's take example number 13, part 1. That is x squared plus 6x plus 9, right? This trinomial needs to be factorized, and how we are going to do that? In order to factorize it, we will use another method that is called splitting the middle term. So, what we will do? First, we will split 6 into 2 parts in such a way that the 2 parts when added, they will give me 6. The sum should be equal to 6 and the product should be equal to 9. So, think of a number, think of 2 numbers that you will multiply, you will get 9, and when you add, you will get a 6. So, think of these 2 numbers. So, we have 2 numbers, 3 and 3. Why? Because if you multiply 3 by 3, you will get 9. And if you add 3 to 3, you will get 6, right? So it means I can split this 6x as 3x plus 3x and write it down like this. Next step is you have to group the two terms together in such a way that something common will be taken out. So here I can group these two together and here I can group these two together, right? So what is common in these two terms? I can see x is common these two terms, right? So I can take out x. So what I'm left with in this bracket, I'm left with x plus 3 over here, right? Now a plus sign is there. Put the plus sign over here. Next, look into this bracket. Look into this bracket. So what is common over here? I can't find any another variable with 9. So it means I can take out 3, right? So if I take 3, what I'm left with over here? I'm left with x only, and here I'm left with 3. So I can see I have something common. I have binomial common in both the terms, right? And that is x plus 3. Now next step is what you will do, you will take this x plus 3 common. Then what you are left with? You are left with x over here, then plus sign, and then 3 this, right? So this is the required result, right? So I hope you have understood how to factorize any trinomial using splitting the middle term. Now let's move on to the next topic. So the next topic is division of algebraic expression. So here in this section, we are going to find out how to divide two algebraic expression, right? So in order to understand that, let's take an example over here. Let's take example number 15. So here what we have to do, we have to divide 40 x raised to the power 3 by 5 x raised to the power of 2. So in order to do that, factorize 40. So I can write 40 as like this, and I can write 5 like this. So dear student, we know that 5 8s are 40. So I can write 5 ones are 5 and 8. Then these 2x will get cancelled out. So what you are left with? You are left with 8 over here, and in the numerator x is also there. So we have a numerator 8x and we have a denominator 1 which is equivalent to 8x. It implies when you divide 40x cube by 5x square, what you will get? You will get 8x as your answer. So dear student, these are the steps that we are going to follow while dividing any algebraic expressions, right? So I hope you have understood this topic. So let's quickly summarize the topics that we have covered in this lecture video. So first of all, we learned how to find out factors of a given monomial. Thereafter, we discuss how to find out common factors of the given monomials. After that, we discuss about highest common factor of the algebraic expression. Thereafter, we learned about how to factorize algebraic expression having common monomial, having common binomial. And then we discuss about how to factorize an algebraic expression by grouping. Then we discuss about how to factorize any algebraic expression using identities. Then we discuss about how to factorize a trinomial using splitting the middle term. And at the end, we have just discussed about how to divide algebraic expression. So dear student, that's all for this lecture. I hope you have understood all the topics. So we will meet you soon in the next lecture. Till then, take good care of yourself. Keep smiling, keep practicing, keep learning.